What caused the ancient Mayans to build gigantic pyramids? What drove astronauts to land on the moon? What compelled Imelda Marcos to collect 3,000 shoes? They were all on dope. Dopamine, that is. Dopamine is a neurotransmitter that has such a wide variety of effects that it can be a bit hard to categorize. And one of the reasons for that is that unlike serotonin, which operates in one circuit, dopamine operates in several. All of the dopamine produced in your entire nervous system comes from neurons, which have their cell bodies in two tiny areas of the midbrain. Most of that midbrain dopamine flows into the basal ganglia, which you'll remember from our study of the limbic system is a structure primarily devoted to movement. Regulating movement is pretty important, but since we're here to talk about dopamine's role as a happy chemical, we're going to focus on the roles it plays in the reward network. We're really interested in the dopamine neurons, which have their cell bodies in the VTA of the midbrain and project up to the nucleus accumbens, a special part of the basal ganglia that helps us process rewarding stimuli. This connection is the reward network, starting with its role in providing you with motivation. Dopamine flowing in the reward network creates that great feeling that a reward is at hand. It gives you the joy that you feel when you find something that meets your needs. The reward network was discovered by a team of neuroscientists, Olds and Milner, who were working in the 1950s. They were studying the limbic system, and they implanted electrodes directly into the nucleus accumbens, the target of the dopamine-rich neurons in the reward network, and they allowed the rats to control when that electrical stimulation was turned on by pressing a lever in their cage. So when these rats had the power to give themselves a dopamine rush, to create that feeling that something wonderful they need has just been given to them by pressing a lever in their cages, they pressed the lever to the exclusion of all else. They stopped their grooming behaviors, they stopped socializing, they stopped exercising. Rats would push the lever till they got sores on their paws and starved to death. So yeah, I guess you could say the motivation provided by dopamine is pretty powerful. So what sends dopamine shooting into our nucleus accumbens and gives us this feeling? For a reminder of the basic biological rewards that all mammals seek, I'm going to turn to a clip from the video on the reward network that I posted when we studied the limbic system. And the reward network is designed to motivate you to pursue resources that will help you survive. So some really basic biological rewards like sex light up the reward network in every species of animal that neuroscientists have ever studied. Similarly, food will light up the reward network in any hungry animal. And this makes sense from an evolutionary perspective. Biology needs you to be pretty dang motivated to get out there and get food, even in the face of danger or adversity, and to reproduce, pass on your genes. So those are two really strong biological rewards. Other things that we human beings find rewarding are wealth and resources. Now, wealth can be money, we certainly find that rewarding, but it can also be any desirable possession, like the Gucci slides I found at the thrift store. For our Paleolithic ancestors, wealth might have been a basic resource, like a piece of bark they knew they could use to make a canoe. We come from a long line of gatherers. Our ancestors walked the woods searching for anything that might be of value in their perilous struggle for life over death, be it food, be it something to build a structure with, anything they could use to survive and thrive. And dopamine motivated that constant search. Because we're social creatures, we also get a big dopamine hit off of the promise of a social reward. So when you hear that notification sound, that means you might have some new likes and comments. You can thank dopamine for the fact that you must stop what you're doing and go check your socials immediately, because a social reward is present and dopamine causes you to be highly motivated to go and get it. We humans, the problem-solving species, are also really motivated by knowledge itself and control over our environment. When you're studying for a math test, dopamine is motivating you. Part of the motivation might be the motivation to get good grades, which is something that you want because it leads to wealth and status someday and gets you social approval. But hopefully some of the motivation comes simply from the fun of problem solving and learning new information. And dopamine is always causing us to seek novelty, to check for a new resource just around the bend. Dopamine creates a lot of ups and downs in our everyday life. To understand this, let's take a moment to consider how dopamine works in our primate cousins. I'm going to show a short clip from a YouTube video by Dr. Loretta Granziano. This film is aimed at younger kids, but it does a great job of explaining how dopamine works in the primate brain.
Dopamine creates the great feeling that a reward is at hand. When a monkey sees a juicy mango at the top of a tree, dopamine triggers the good feeling that a need is about to be met. That motivates the monkey to climb the tree, and more dopamine is triggered each time the monkey sees the mango get closer. When the luscious treat is all eaten, dopamine stops because it's already done its job. Now the monkey scans the world for another dopamine stimulator, which will meet another need.
This is why dopamine is all about pursuit. It actually stops when it's time to enjoy the reward. So when your phone pings and you check to see if you have any new likes or notifications, the actual enjoyment of that social approval comes from serotonin. Dopamine has dropped because you've obtained the reward. In a few minutes, you'll be hungry for more.
Dopamine surges in a lion when it sees a gazelle it can catch. That releases the lion's reserve tank of energy. A lion who ran after everything would starve to death because it wouldn't have enough energy when a good opportunity came along. Dopamine is the brain's signal that now is the time to go for it. You may wish you had that excitement every minute, but a mammal survives by making careful decisions about when to invest its energy.
So dopamine helps us to arrange our priorities. It convinces us to put our energy into what is most important for our survival. Human beings aren't great at enjoying what we've got, and this comes from the legacy of our ancestors. They never stopped seeking either. When their bellies were full, they looked for new ways to meet their needs by building better arrows and stronger shelters. We know how hard they searched for the right materials because in Paleolithic archaeological dig sites, we often find items from many miles away that must have taken a great deal of energy to obtain. Dopamine made that quest feel good, but the thrill soon passed and they kept searching for more. In addition to creating the motivation that fuels our drive to chase rewards, dopamine plays a big role in learning. Dopamine teaches us how and where to get the things we want. To understand the way that dopamine shapes learning, I want you to think about your favorite fast food indulgence. Okay, let's think about what was going on with dopamine levels in your brain the very first time that you tried this delicious fast food treat. So here are your dopamine levels in the time leading up to that delicious cheeseburger. And you can see there's some natural ups and downs. And then at the moment that somebody hands you for the very first time this amazing, delicious cheeseburger, a very unexpected reward, you get a big surge of dopamine. Dopamine really gets flowing for an unexpected reward. That's why finding a 20 in the pocket of jeans you haven't worn in a while is incredibly exciting because you didn't expect the money to be there. But if you have $312 in your bank account, looking at your balance and seeing that $312 doesn't deliver a particular thrill because you knew that resource was in place. It wasn't unexpected. There was no surprise. The reason we get a big flood of dopamine for a surprising reward is because this is a cue that we have the opportunity to learn something that's going to allow us to get this reward again in the future. This dopamine surge actually kicks off a learning process in your brain. This dopamine surge actually causes your brain to look back over time and analyze all of the things that happened just before the reward was delivered and figure out what was related to the presence of the reward. Its goal is to analyze these past events and figure out which ones have predictive value. In other words, which ones will help you know when burgers are available the next time. So in this case, it's the sign for the burger restaurant and the sight of the burger on the fast food menu. Okay, now let's check out what dopamine is doing in your brain the next time you go for the burger. This time, you get a surge of dopamine for the predictors, these cues that signal that a reward is present. So you're going to feel your craving and your desire and your anticipation for these events that signal that a burger is coming. Look what happens when you actually get and eat the burger. Not much. The reward network doesn't really care about the burger now that you have it. It's ready to move on to creating craving for the next reward that it wants you to pursue. And every time that you see these particular cues and then order the burger, the learned association between these cues and the reward gets stronger and stronger. Dopamine actually prompts neurons in your brain to grow and change, representing this new learned association. Okay, so this is the case where you expected a reward and you got it. Let's think about what would happen if that reward was actually not delivered. So what if they're sold out of burgers that day? When we expect reward and don't get it, dopamine plummets. Plummeting dopamine feels crummy, but the brain does this for a reason. Low dopamine causes it to reassess these cues and question whether they're really reliable predictors of the reward's presence. Or this constant process of refining our ideas about what signs indicate a reward is present is at the heart of learning. So in the presence of a reward, dopamine boosts your motivation to pursue that reward at all costs. It gives you super learning powers so that you can become an expert on which cues will predict that the reward is available in the future, and it captures your attention, giving you laser focus on the rewarding stimuli. I'm using this worn-out meme from a couple of years ago to illustrate how powerfully the reward network directs our attention. So here we've got rewarding stimuli in the environment, and the reward network is responding. Now, we'd presume that the jealous girlfriend in this image is the rest of your brain, but we've got to correct the meme a little bit because dopamine's hold on your attention is powerful, and it will direct a lot of your mental resources to learning about how to get this reward again. So we'll talk about disorders that arise from too much or too little dopamine in a moment. But right now, I want to describe what it feels like in your brain when your dopamine levels are within the normal range, but just a little higher than usual or a little lower than usual. So when dopamine's a little bit high for you, when you're in the presence of a reward or working on something you feel really motivated to complete, you feel happy, you feel very excited, you feel creative. Your brain is ready to make connections and solve problems. It's a great feeling. When your dopamine levels are a little low, you feel dissatisfied and impulsive. You're desperate for more dopamine. You also have trouble concentrating. Dopamine plays a big role in focusing our attention. What's a situation where your dopamine levels might be a little bit low? Sleep deprivation. It turns out that when we're deprived of sleep, one of the dopamine receptors in our brain stops working. Without that receptor to receive dopamine, we're in a dopamine-deprived state the next day after pulling an all-nighter. And you know what sleep deprivation feels like. You can't concentrate, you're often much more hungry than usual, and we tend to crave sweets and junk food. It's also a time that people are more prone to making impulsive decisions and engaging in unhealthy things to get that needed hit of dopamine. Low levels of dopamine are implicated in attention deficit hyperactivity disorder. Remember, dopamine plays a key role in focusing your attention, helping you order your priorities, pursue the important stuff, and leave other things until later. Without enough dopamine, those functions don't work properly in the lives of folks with ADHD. And most of the medications used to treat ADHD do so by increasing levels of dopamine in the brain. Every drug that has the potential to be addictive, from coffee to cocaine, operates by hijacking your brain's reward network. Drugs create an artificial boost in dopamine that causes you to devote the motivation, energy, and attention that you would ordinarily dedicate to natural rewards to the drug instead.